The next section is ingesting data. And this is kind of the logical progression of like, hey, once you've played around with Iceberg, you've kind of selected and figured out how do I want to set up a catalog implementation. The next thing is to actually really get data in. You want to learn early on how to kind of work with the Iceberg data, how it grows over time. That's been particularly challenging. We'll talk about a little bit of that later in terms of maintenance for Iceberg tables. But one of the most important things is just ingesting data. And if you have existing Kafka infrastructure or other streaming infrastructure that you're using, a really good approach is to just fork off of those topics a separate set of tables that are Iceberg so you can do all of your comparisons and whatever kind of migration validation that you actually need. But if you're starting new, there are great ways to get started very quickly and land data with good schema, with structure and things like that. So the first thing you want to do is, as you land data, you want to apply structure, and that's really what Iceberg is providing. Strong schemas, strong guarantees around the data integrity, and you want to do this as early as possible. There are obviously streaming use cases where you want to have a Flink and you want to be operating off of data live, but you almost always want a representation landed as quickly as possible that is accurate to whatever came through the stream. You don't want to lose fidelity of your data because it can be really difficult to either reconstruct that or understand where the problems came from if you've got something that's actually mutating that data between the actual upstream and landing it into an Iceberg table. The last piece is deferring work. This is a major concept within Iceberg, is that Iceberg's protocols for commit and the way we think about commit semantics allow for things to operate on data behind the scenes. So you can do background processing, some of the maintenance activities. If what your goal is to land data as quickly as possible, make sure it's durable, take pressure off of the upstream systems that are, the pipelines and things like that, then you want to make sure that you aren't doing extra work in that path. So if you try and couple, compaction and optimization and various other things in that landing of data, it's more likely to break. It creates more of an operational burden. So that's why we kind of separate these concepts, and you don't do like inline compaction as you're landing data. You defer that work till later. There are a number of different like open source technologies. Kafka is probably the predominant one in terms of like building an actual event pipeline. There are many other like processing engines that you can use to actually consume from Kafka and write to Iceberg. Flink, Spark, Kafka Connect are all good options. They kind of have different use cases. I would say Flink is fully capable. It's probably one of the most capable, stream processing engines. But if you're using Flink, that also means that you're probably doing a lot more work there than you need to in order to just land it as Iceberg data. You can, of course, even point Flink to a table and treat the table like a stream. That would be good for doing more complicated processing on the landed data. But if you're just trying to get data into your warehouse, Kafka Connect is probably one of the best options. We'll talk about that in just a minute. Spark streaming, I haven't really used that a whole lot. We do see a few people in the community that are using Spark streaming, so we know that it works to some level. I would say that if you are Spark heavy and you don't want to take on the maintenance burden of some other technology like Flink or Kafka Connect, if you don't already have that in your ecosystem, Spark is a great option to keep your maintenance and your ecosystem kind of clean and land data directly from your upstream systems. Pulsar is another stream processing platform, and they have an Iceberg Connect. I haven't looked into the details of it, but I know that they document that as a path to landing data quickly into Iceberg. And then the last one here is there are a lot of use cases for just getting unstructured data into an Iceberg warehouse. And this is where things get a little bit more complicated. You have the option of using something like Spark. I would say in the past, that's typically what data engineers would do. You've got some new JSON structure or Parquet files that are just being dropped in directories. And you use Spark to go load those things up, apply schema, add structure to it, and land it into your warehouse. I would say that there are a lot of vendor solutions for doing this kind of thing. The Fivetrans, the Upsolvers, Tabular has file loader capabilities. So, you can go grab files wherever they happen to be, apply structure automatically, and load them into your warehouse. a lot of this is kind of like unnecessary data engineering for common problems. And that's a big part of what a lot of these companies are trying to solve and make easy for you is don't spend your time doing that. Spend your time working with real data engineering challenges, not just applying schema to JSON. So I mentioned Kafka Connect as being one of the best options. Tabular actually built a Kafka Connect implementation, and that was largely as a response to we saw there were a number of implementations out there, and they had issues with how they would scale or some of the approaches that they took in terms of, converting data into Iceberg format. So we built this Kafka Connect implementation, and we're actually in the process of donating that to the upstream Iceberg. So a few of the initial PRs have already gone in. It's an extensive review process, and we're making changes to make sure it really kind of adheres to the mentality of the project. But the main features are exactly once delivery, multi-table fan out, and that's really important because you don't want to have to increase the amount of infrastructure based on the number of topics or streams or tables that you want to produce in your data warehouse. So if you were a very Flink heavy shop, you may have like one Flink job per table, but if you have 1,000 tables, that's 1,000 Flink jobs. And that's similar to how some larger companies run, just because they have the infrastructure to support that. But you can actually get quite far with a Kafka Connect that's doing multi-table fan out. That can be dynamic, so it automatically creates tables. It can automatically do schema evolution, though it does that in a non-destructive way, so it won't like remove fields, it'll only add those, and then your data engineering teams can kind of decide, well, what does the final version of that table look like, and then modify that schema on the table itself. And that's one of the great things about it is it's actually using the table schema to map the actual properties as they're coming through. And the last thing is about scalability for this. Commit coordination was a big problem with a lot of the implementations, and that's something that we addressed here. So you don't get a lot of different workers that are all trying to commit really small incremental changes to the table. It pollutes the table metadata. It creates a lot of contention. This is the kind of thing that the latest iteration of the Kafka Connect addresses. So the best practice here, again, is land your data immediately. You want to get your data in and into a structured and kind of durable format as quickly as possible.